Okay, so AQA Pure Core 1, Summer 2010, question 3. And the question says, the polynomial px is given by px equals x cubed plus 7x squared plus 7x minus 15. Use the factor theorem to show that, this is part A, use the factor theorem to show that x plus 3 is a factor of px. Okay, so what we want to do here is if x plus 3 is a factor, and you make that equal 0, then x equals minus 3. So we're going to basically sub x equals minus 3 into this polynomial. So when p and the x equals minus 3, we get minus 3 cubed, and this is just subbing minus 3 into this, plus 7 times minus 3 squared plus 7 times minus 3 minus 15. And when you multiply all of this out, so minus 3 cubed is minus 27, plus 3 squared is 9, times 7 is 63, minus 7 times minus 3, so 21, and minus 15, and that all equals 0. Therefore, x plus 3 is a factor. Okay, so let's go on to part 2, part A. And it says, express px as a product of 3 linear factors. Okay, so in my opinion, this is the hardest part of the question. So, first of all, we know that x plus 3 is one of the linear factors because we've just shown that. So we want to get the rest of, the first step is to find out that if you divide, if you divide the polynomial by x plus 3, what you are left with, and it should be something that looks like that, a quadratic formula. So to do that, we do long division. So if we go x plus 3, and we're dividing x cubed plus 7x squared, because that's our polynomial, plus 7x minus 15 by x plus 3. And we do this by saying, okay, so what are we going to times x cubed by? What times x equals x cubed? So that's x squared, right? So we go x squared times x is x cubed. X squared times 3 is 3x squared. And then you multiply these, so that's going to be 0. I mean, not multiply, subtract these. So that's going to be 0. 7 minus 3 is 4x squared. And then just for ease, let's write what the next value is just there. Okay? So we can see this clearly. What do you times by x to get 4x squared? Well, that would be 4x, because 4x times x is 4x squared. And then we're going to times 4x by 3, so that's plus 12x. And then again, minus these, so 0. 7 minus 12 is minus 5x, and then let's just add the next term, so it's down here and we can see it nice and easily. Okay, so what do we times by x to get 5x? Well, that would, minus 5x, sorry, so that would be minus 5. And let's just do this all out to prove that it is actually working. So minus 5 times x is minus 5x. Minus 5 times 3 is minus 15. And of course, if you subtract these from one another, we're just going to get 0. So this is this quadratic that you're looking for, right? So px equals x plus 3, and then this here. So x squared plus 4x minus 5. But the question wants it in 3 linear factors. So to get 3 linear factors, let me just adjust. We're going to have to make this into, separate this up. So we do that by, let's just write this out. We do this, you should have done this before, you'll know how to separate this up. So what two numbers multiply to make minus 5 and add together to make 4? And that is minus 1 and 5. So this is your answer. Okay, part B. That says, use the remainder theorem to find the remainder of P when Px is divided by x minus 2. Now again, like the first question, when x minus 2 equals 0, x equals 2. So we're just going to plug x equals 2 into the polynomial. So when x equals 2, we have, and we're plugging this into the original polynomial, this. Or you can plug it into this because it's the same thing, but just into the original one for ease, we're going to go 2 cubed plus 7 2 squared plus 7 times 2 minus 15. And we will find that all of this, if you multiply it all out and whatever, you're going to get 35. And that's the remainder. Okay, so now going on to part C. It says verify that P with minus 1 subbed in as x is less than P with 0. So let me just focus that. Okay, so subbing in minus 1, we get, this is into this original polynomial. Okay, so we get minus 1 cubed plus 7 times minus 1 squared plus 7 times minus 1 minus 15. And this is going to be minus 1 cubed is minus 1. Minus 1 squared is 1. So plus 7 minus 7 minus 15. And that is going to equal minus 16. Okay, now let's plug the 0 in. So when you plug the 0 in, you're going to get 0 cubed plus 7 times 0 squared plus 7 times 0 minus 15. Obviously, all of these cancel out because you times them by 0, and we're going to be left with minus 15. And it's easy to see that minus 16 is less than minus 15, so we've proved that this is correct. So the polynomial with minus 1 subbed into it is in fact less than the polynomial with 0 subbed into it. Okay, and on to the last part, which is the second part of question C. It says sketch the curve with the equation y equals x cubed plus 7x squared plus 7x minus 15, indicating the values where the curve crosses the coordinate axes. Okay, so to do this, we know that split into 3 linear factors, we have x plus 3, x minus 1, and x plus 5. Therefore, we know that the curve crosses the x-axis at the points x equals minus 3, x equals 1, and x equals minus 5. Okay, so whenever y is 0, they're the values that x equal. Okay, so when x is 0, from what we found here, when x is 0, y is going to equal minus 15. And again, it's always about, like, if the question's got a second part, you can probably, 9 times out of 10, you can use the first part to help you with the second part of the sub-question. Okay, so we know that when x equals 0, y equals minus 15, and when y equals 0, x equals minus 3, x equals 1, and x equals minus 5. So let's draw some axes. I mean, use a ruler in the exam probably is a good idea, just to like get it nice and neat for the examiner, so it makes it easy for them. And we know that when y equals 0, x equals minus 5. So it's going to cross the axis at this point. X equals minus 3. So about here, it's going to cross the axis at this point. And x equals 1. And when x equals 0, y equals minus 15, so it's going to cross the y-axis. Let's just put minus 15 just here, even though it's probably not that to scale. It equals minus 15 down here, right? So because we know that the graph dips here, we know that this is going to be like this, and then it's going to come around like that. Okay? And that is the graph. I mean, you can kind of check that the graph is positive here by plugging one of these values of x into the quadratic if you've got a bit of time left over, and you can check that the graph's negative, the y value is negative here by subbing one of these x values into the polynomial. But that's the answer that the mark scheme is looking for. Thank you for watching, and I hope this was helpful.